Hello and welcome to using the ensure assertion, which is going to be pretty cool. I think I may be saying assertion through the video. So if you hear me say that, just laugh for me. I mean assertion. So what's going to happen is we cannot aim at the moment, and what we're going to have by the end of the video is a very, very, very useful log message that comes out that tells us precisely why we can't aim, because we have a problem with a pointer and it tells us exactly where in the code to go look. So this is going to be a super useful new pointer protection paradigm. I'll see you in there. So I want to get this pointer working, but also I want to get aiming working. Now it's interesting that my game driving still works. I can still move my tank forward and backwards. That's not a problem. Not quite sure why the AI tank's not moving. He's probably just stuck. It's not something we need to deal with right now. I'll pop another one down just to check. So yeah, the AI tanks can move, but none of us are aiming, neither us nor the AI tanks. What is going on there? Well, what is good is that we failed graciously. The program is still running. What is bad is we're masking some pretty nasty problems, which is we've got null pointers. Now, the way that we currently do our pointer protection, if you have a look, if not get controlled tank, that's a typical one, then return. So if we can't find the pointer, we don't execute the functionality, and I like that. I think that's good. But what's bad is we have no idea that we've got null pointers, and we're not entirely sure right now why we can't aim. Now we can trawl through and work out what's wrong and why we can't aim, but we don't have to do that, and we want to know very early that our pointers are null and that other major errors are happening. So let's talk about my brew or my criteria for Ben's game error handling criteria. Okay. So I think that executions should continue if possible, that our design should be sufficiently modular and separated, that if something goes wrong, it doesn't take everything else with it, i.e. the aiming is not taking the movement with it. We must get a helpful warning, ideally with a line number. Sounds like it's asking a lot, but there is a solution. We want to know exactly where in our code this is going wrong. We can compile out the checks for production if we like, or we could organize that those checks, that the logs, when it crashes, get written to a log file that could be sent back to us, the developer, with a line number. That would be ideal. So the solution is this. Instead of doing things like if not left track and right track return, I know we do something slightly different, but you get the idea, that becomes if not ensure left track and right track return. Now this ensure is a very special macro keyword. It's something called an assertion. And what it does is it goes and checks that the condition in the brackets, the left track and right track, is true. And if it is, it's fine, it just carries on. But if it's false, i.e. not ensure that stuff in the brackets, then we return and we continue to execute, which is great. But the fact that ensure has run means that it will write a load of very, very useful stuff to our console. Let's go and find Unreal's docs about assertions. Here they are. You can just look for Unreal assertions. And this is also in your resources on Udemy. You can have a quick, in fact, as a little micro exercise, just pause the video, have a quick scan through this. Take just 30 seconds to have a quick scan. Look particularly at the last bit of it. Cool. So look, if we scroll down, we've got this thing here called ensure. It tells you a little bit more about what it does. And this is the type of pattern. If ensure, blah, then do that. Okay. So it's very cool. We want our assertions to these conditions to always be true. We never want these to happen at runtime, but it's incredibly helpful during development to put these in place. Now, I want to just give a tiny bit of credit here. Just at the right time in production, I'm not sure how to say his name, Ghislaine, probably, here from Canada, brought this issue up, we discussed it, and as quick as that, we've put it into the course. There's a more detailed discussion over on the community site, which is here, and I will put both of these these references for you into the resources. So it shows that if you bring things up at the right time in the course, I'm happy to adjust the course and add some value. So thank you very much for that suggestion. Okay, let's get on with it. Let's do it. Let me show you how to do it first. Let's do it with this not get controlled tank. What we do, if we say, if not ensure get controlled tank, being careful with our brackets, then return. All right, let's just move on through these now. I'll do one more with you. I'm going to look for return to start with as a quick way of going through in the entire project. And if not ensure, no, I won't do that one. I'll leave that one to you just because I want to find a different pattern. Here you go. Here's the one that I used in the example. I'm going to change the logic round. If not ensure, then left track and right track. I just think it reads better. like that. Or you could say if ensure left track and ensure right track if you wanted, but this will do. The same thing, we'd use exactly the same pattern down here in the other one. Okay, I've done enough of it for you. You're going to have to work out the logic for yourself for the other bits. Indeed, that's going to be your challenge. Is I want you to use ensure everywhere. Add ensure to all your pointer protection. You can't rely on searching for return semicolon, by the way. It's not the only way that we are doing pointer protection. So look through your CPP files. Find the null pointer that's stopping aiming. And celebrate. Don't fix this null pointer yet. It's an architectural issue we'll sort out in an upcoming video. But just celebrate the amount of detail you get here when you actually see this log for the first time. By the way, sometimes you'll need to close and reopen it in Unreal. If ensure's already run once, it may not run every single time you run. So that's just a heads up. But see if you can see this thing working. It's really satisfying when it helps you find the problem. Okay, welcome back. Let's do this. I'm just going to carry on through the code now, starting by looking for returns because they're the quick wins. So if not ensure barrel, in fact, I'm even going to copy the ensure open bracket because I think I'm going to be using it a lot. If not barrel or turret, I'm going to show you the other way here just to show that you could say if not ensure barrel or not ensure turret. You could do that and give two different ensures. It'll be a little slower, but you'd know whether it was the barrel or the turret that was missing. Okay, that's all the returns I can find. Let's now go through the CPP files and see where else we do this. We don't do anything there in terms of pointer protection. Let's look at the tank. If not tank aiming component, return. Okay, so we need to put one in there. If not ensure tank aiming component, return. Where else have we got it? Not sure why that didn't come up in that search. Maybe I didn't go around enough times. If barrel and is reloaded. Now think about this. Is reloaded is not something we want to do an ensure on because it's part of the logic of the game. It's not a problem if reloaded is not the case. So I'm actually going to change this round. I'm not going to protect the barrel here. I'm going to take that out. I'm just going to say if is reloaded. And then I'm going to put a much more standard protection of the barrel here. If not ensure. Oops, I haven't got it in the copy buffer anymore. Ensure barrel return. We'll go for that standard pattern there. If not ensure barrel return. Okay, let's keep looking. Tank AI controller. If ensure player tank. Or you could say if not player tank, if not ensure player tank return at the top. But let's do it this way here. I want to show you a variety of different ways of doing it. It's important you understand how it works rather than just using a recipe. I don't see anything else in that file. I'm just working through my files. Nothing in there. Nothing in there. If ensure aiming component, it's a pointer that we need to protect. Possibly this get look direction should pass, but I'm going to leave that one because it's not a pointer, it's a function call. Okay, nothing in the track or the turret. Okay, let's go ahead and compile now. Just going to sort out my output log. I think I want it. I do want it at the bottom of the screen, but I think I want this details to be on the right. So, something like that. So I've got a syntax error. Barrel undeclared. I did see that. Tank CPP 37. I put a double L where I should have put a single L. Apart from that, we're doing well. Hey, that rhymed. I put a double L where I should have put a single L. Apart from that, anyway, forget it. Forget the jokes. Let's just get the compilation going. All right, fantastic. We're going to clear the logs and play the game. Now, so what happens when I play the game? There's quite a long pause. And then, if we search the logs for ensure, you'll see here, the tank aiming component has failed here, battle tank, tank CPP line 31. How useful is that? Tank CPP line 31. It's this that's failing. And we know it is because, remember, we used to add it as a default sub-object and then we never actually got around to fixing it, and we've got an architectural decision about how we're going to fix that. In fact, we're going to fix it in the very next video. Congratulations on getting to grips with the ensure keyword, and I'll see you in the next video.